morning all of you. This is your Prabhakar and welcome to our channel Dawn of Chemistry. In this video we are going to discuss about the Hess Law. In thermodynamics, whenever you are doing problems, complicated problems you are doing, means to understand that problem, Hess Law is very important thing. So Hess Law of constant heat of summation. Even in your chemical bonding case, when you are studying about the Born-Haber cycle, there we will be getting this Hess Law application. Now let us see what is Hess Law, what are the applications of Hess Law and how to do problems based on this Hess Law. Let us see this. Hess Law of constant heat of summation. What is this Hess Law of constant heat of summation means? Let us see the statement. If a reaction happens, if a reaction occur in single step or multi-step, if a reaction occur in single step or multi-step, the total energy change happening in a reaction, if a reaction takes place in single step or multi-step, the total energy change happening in the overall reaction is same. If a reaction takes place in single step or multi-step, the total energy changes taking place in the reaction will be same. Let us see a chemical reaction. A gives B. So there is a chemical reaction. A gives B. Let us take enthalpy of reaction is X. This is a single step. So this is one path where A and B, A will be directly converted into the B. There is another method. A forms C, delta HR is equals to P. C gives D, delta HR is equals to Q. D gives E, delta HR is equals to R. And E gives B, delta HR is equals to S. So here you see same reaction. A is forming B, here also same reaction. Finally you are getting B. This is happening in single step, this is happening in multi-step. If a reaction takes place in single step or multi-step, the total energy change will be same. So here X is equals to P plus Q plus R plus S will come. This is nothing but the Hess Law. If you eat food directly, take food like this and eat like this, or take food like this and eat like this, you will get same amount of energy. That's what Hess Law says. If a reaction takes place in single step or if a reaction takes place in multi-step, total energy change in the reaction will be same. That is the Hess Law. The most important application of Hess Law is finding the lattice energy of substances and finding the hydration energy of the particular compounds is very important thing, and finding the solvation energy and finding the dilution energy or enthalpy of dilution or enthalpy of solution. These are the very important applications. Now let us see how to find the lattice energy by using this Hess Law. I think you might have studied this thing in your chemical bonding. Let us see. Sodium solid and chlorine gas combine with one another and forms NaCl solid. Let us take the heat liberated is enthalpy of reaction. Hope you are very clear. Sodium solid, chlorine gas directly combine with one another and forms NaCl. Amount of heat liberated during formation of 1 mole of substance from its constituent elements in their standard states is the enthalpy of reaction. That is enthalpy of formation. The same reaction can happen in some small steps. What are the small steps? Means Sodium solid will be converted into sodium gas. Chlorine gas will be converted into chlorine atom. If you remove electron from this thing means sodium cation. If you add an electron means you will get chloride ion. The sodium cation and chlorine anion will combine to release some amount of energy. This is nothing but the lattice energy. Amount of heat liberated during formation of 1 mole of ionic compound from its constituent ions when they are at infinite distance and they come close and forms this compound. That is nothing but lattice energy. So see, solid to gas means enthalpy of sublimation. Gas to atom means bond dissociation energy. Here 1 mole is there means bond dissociation, half mole is there means bond dissociation energy by 2. Energy required to remove electron from an atom is called as the ionization energy. Here you see, if you study all these things for 1 mole, so that's why ionization energy will be for 1 mole itself, and enthalpy of sublimation for 1 mole. And here you see, energy released when an electron is added is known as electron affinity. We know electron is added means energy is liberated, so it will be negative, and when they combine they will release lattice energy. So this is nothing but Born-Haber cycle. Let us see, according to Hess Law, enthalpy of formation is equals to enthalpy of sublimation of sodium plus bond dissociation energy of chlorine by 2 plus ionization energy of sodium minus electron affinity of chlorine minus lattice energy. So lattice energy equals to enthalpy of sublimation of sodium plus bond dissociation energy of chlorine by 2 plus ionization energy minus A of chlorine minus enthalpy of formation. Here you see, half only we will take electron affinity. By half we will take means only 1 chlorine atom we are taking. So that's why we will be taking half only. 1 mole of chloride ions will come, you can continue. Here it is 1 mole of chlorine gas means 2 atoms will come. Since 1 is there, you can take as. Like this, we can find lattice energy. Number of problems they will give in exams. Here I have taken this one, but they will give you some other substance. They will go for NgCl2, they may go for AlCl3, they may go for CaCl2, they may go for KCl. Anything they can go, and they will ask you one of the missing parameter of anything I have written here, and they will ask you find out that thing. And one model is there, another one. Let us see, enthalpy of solution. How to find this enthalpy of solution? Already I have explained these things. What is enthalpy of solution under? See, copper sulfate anhydrous. When you take copper sulfate anhydrous, add water, it forms copper sulfate 5H2O. This is hydrous. Copper sulfate 5H2O with excess water, it forms copper sulfate solution will come. So amount of heat liberated when 1 mole of substance dissolved in 1 liter of water is known as enthalpy of solution. Amount of heat liberated when 1 mole of substance is hydrated is known as enthalpy of hydration. So this is, you see, and you see anhydrous salt dissolved in water means this is known as enthalpy of solution for anhydrous. So from this what you can write, this is a single step and this is a multi-step. So enthalpy of solution for anhydrous salt is equals to enthalpy of hydration for anhydrous plus enthalpy of solution for hydrated salt. Like this, we can do problems based on this Hess Law. So that is the thing regarding what is Hess Law and what are the important applications of this Hess Law. Be careful with this Hess Law. Number of problems they can ask you based on this Hess Law of constant heat of summation. That is the thing regarding this Hess Law. Try to like the video, share the video with your friends, and any doubts you have means you can put in the comment section. Subscribe to the channel for more updates. Thank you.